In this section, we're going to talk about units of measure. So units of measure in science are SI units. So SI is actually French, and basically it just stands for, in English, the International System of Units. Okay, so it is a standard set of units of measure from which all other units of measure can be derived. So you can kind of do unit conversions from these, which we'll talk about unit conversions later, in order to get any other unit that's not included as one of the 7 SI units. So there are just 7 SI units. They're right here. So you have the meter, the kilogram, the second, Kelvin, amperes, moles, and candelas. So meters, kilograms, seconds, we're all familiar with. You may know Kelvin. That is one of the scientific temperatures. In science, you generally use either Kelvin or Celsius. Electric current deals with amperes. We're going to deal with moles in physical science and chemistry. And then candelas are actually luminous intensity. So that deals more with like light bulbs and things like that. So we're going to look at exactly how these standards are calculated. You don't have to have this memorized. This is more just for kind of so you know what it is. It used to be that each of these SI units actually had a standard, a physical standard somewhere in, I think it's Paris actually. They had like a museum, well, kind of like a museum with all of the physical standards. Right now, the only one that still has a physical standard is the kilogram, and they're actually working on getting rid of the physical standard because it's not so standard anymore. But most of these you will see are based on some kind of like constant in nature. Okay, so for example, a meter is the length traveled by light in a vacuum in that fraction of a second. So it's basically 1 over close to 300 million seconds. Okay, so very, very tiny amount of time, but light will travel 1 meter in that amount of time. Kilogram, okay, so again, there is actually a prototype, and then they will every once in a while take the prototype out in order to create other prototypes from it that then go around the world, and that's how we get our scales calibrated, different things like that. Second, again, this is down to radiation, actually. So this is a constant time, okay? So it deals with the cesium-133 atom. So again, relatively difficult to measure, but it is a constant. So the ampere, again, this is more for interest than you need to know this, but you can see how detailed some of these standards get based on trying to get that exact amount so that it is standard. Okay, so Kelvin is actually based off of water. So, and then the mole is based off of carbon, carbon-12 to be specific. We'll get more into the mole later with physical science and chemistry, and you'll understand why carbon is such a big deal. You'll get that in biology as well. And then candela, okay, so yeah, this one is kind of weird. I mean, a lot of them are weird, but that one's especially weird. Alright, so units of measure actually allow scientists to understand the observations recorded by others. So you will hear me ask for units all the time in this class. It's another kind of big thing with me, because if you don't have units, then the number doesn't actually matter, okay? Because if you say 25, okay, that's great. 25 what? 25 years, 25 inches, 25 seconds. Very different amounts, or very different observations, basically. So units are a really big thing with me. Okay, so imagine if someone told you that an item was 5 long. Okay, you've got a lot of different units for length. So inches, meters, millimeters, miles. It's a vast distance covered with those 4 units there. So you do have to specify what units you're using. Okay, so 5 meters is incredibly different from 5 miles. Okay, so using universal standards, which in this class we're mostly going to be using the metric system. It is the standard system for science, though we will talk a little bit about the imperial system, which is what we use in our daily lives in America. We're one of only a few countries that still uses it. I think there are like 5 in the world that still use the imperial system. But by using these universal standards, you can say 5 meters to somebody in, say, Australia, and they will know the exact length that you're talking about. Okay, there's actually a story with NASA was partnering with another space exploration program, I think in Europe. And the Europeans were using all of their units in metric, and then the Americans were using the imperial system. So they were not very careful with their units, but they were both building components for, I don't remember if it was part of the space station or just a shuttle, but when they got together to try to put everything together, nothing fit. So units are very important. Okay, so standards are maintained by the BIPM. Okay, so again, this is in French. It's the International Bureau of Weights and Measures. Okay, I don't know why France is so big on standards, why they have them, but they do. So, all right. So these are some prefixes for your units that you will need to know. These will actually get tacked on to the start of any of your base units. So like liters, grams, things like that. Okay. So you can say an exagram. That is a thing. We'll get into scientific notation in a little bit, but yeah. So you can see an exagram here at the top is absolutely huge. Okay. So, but then when you get down to a decigram is actually less than a gram. It's 1/10 of a gram. Right. So on and so forth. So you will need to know at least from giga down to femto, okay, and you'll need to know the scientific notation for them. So like giga is 10 to the 9th, okay, mega is 10 to the 6th, and then when we get into kilo down to milli, you'll see that it's actually a step of 1 for each exponent. Okay, so you've got your base here is just the 10 to the 0, okay, because 10 to the 0 equals 1, right? And then you step up to 10 times, 100 times, 1,000 times, and then you go up to 1,000,000, then 1,000,000,000, so on and so forth, okay? So it's these 3 right on either side of the base unit that are a little bit more specific, okay? So hopefully that makes sense. If not, it'll make a little bit more sense once we deal with scientific notation. But the most common prefixes, so kilo, hecto, deca, deci, centi, and milli, can be remembered using King Henry died by drinking chocolate milk. Doesn't make sense, but okay. So you've got the first letter of each word in this sentence, so K, H, D, B, D, C, M. Right, where your B is your base. Okay, so King Henry died by drinking chocolate milk. Also is kilo, hecto, deca, base, deci, centi, milli. Okay, so that helps you remember the order. And then I'll show you in class kind of a way to convert between the two really easily. Okay, between any two on this list really easily. Okay, so we'll go over that part in class because it's a little bit easier to explain in person. Alright, so measurements quantify your observations. So it basically puts a very specific number to your observations. So length, you have a measure of the straight line distance between 2 points. Okay, because remember the shortest distance between any 2 points is a straight line. You've got mass, which is a measure of the matter in an object. It is slightly different from weight. Okay, that factors in gravity, the gravitational pull. And then you also have volume, which is a measure of the size of a body, an object, or a region in three-dimensional space. You also have weight. Okay, so measure of the gravitational force exerted on an object does factor in mass there. Alright, so I'm going to actually put this in a second video, so we'll pause here for right now.